Let's see. I'm not sure what I want to do. Oh, microphone's on. Hello. Okay, so it's like what, 12:37? Okay, cool. So I'm like, I have like 2 monitors and I have like a million windows open over here to like do the stream, and I'm like, I'm always like back and forth, like what's the best setup? Okay, so this week we're going to talk about variables. So we're going to introduce the concept of variables. Last week we did like your first kind of introduction to code, and you had to submit your self-portraits. So let's see, what are we going to talk about today? We're going to talk about, a little bit chilly in here. We're going to review some stuff. We're going to talk about variables, data types, naming conventions, basic operators, some interaction. If we get into the last stuff, we will, but you're probably like, I don't know what any of this stuff is, which is okay. So one thing that we did not talk about last time that you may have seen is something called setup and something called draw. Has anyone seen that in any of the documentation or anything you've seen online? If you've like gone to the reference page or found anything? Anyone familiar with this? You can just reply in the chat, like over yonder. So we have here setup. So setup is something that is like, I mean, everyone is familiar with setting something up, right? Like you've set up like a TV if you buy a new TV, or you've set up a computer if you buy a new computer. Typically a setup is something that happens hopefully once, or like something that happens in the beginning to get everything ready to go. And so we have like, this helps us to organize our code. So when we want to have things that we want to set up in the beginning of our sketch, we will put it inside of void setup. So void is the type of thing it is, setup is the name. We'll get more into what that means exactly later, but the important thing right now is that you should know that setup is something that runs only once, and then we have something called draw, and draw is where we actually have it will basically, you can imagine that when you run your script, your sketch, it will run through each line of code. So when you had your self-portrait, you would draw like an ellipse, and then you would draw a rect, right? And then like depending on the order it was in would depend on what was drawn first or second, like on top or beneath something else. And so what happens with draw is it actually goes through and executes the code line by line, and when it gets to the very last line, it starts back over to the first line within draw. And so like we say it loops because it goes back and forth. So this is important for two things, for interaction and for animation. So animation is something that happens over time. So when you think about animation, you think about different frames of anyone taken an animation course before? So we have, you know, like if you have like someone walking, you have like the first frame, and then you have the second frame, the third frame. Which one are you taking, Zach? Taking 2D design, is that the one you're talking about, Barshar? And I gotta like cheat and look at your names over here to like match up with your username. 107, concepts in animation. Is that this semester? You said this semester. Yeah, so I don't know how much animation you get into in GD105, but yeah, definitely like the main introductory animation courses are like GD107, concepts in animation. And then GD108 is not an animation course, but it touches on a lot of things. And then you can get into things like GD207, which is 3D computer animation. Also, if you're taking GD110, I'm just throwing all the names out here. GD110 has a little bit of animation in it too. That's visual design for games. So if we were to look at this in code, we might put something like setup at the top right, and then inside of setup we have a line of code. So that's something familiar. It's size. Does anyone remember what size does when you write it in processing? So it has like size, then it has the first parameter here, which is in this case 480, comma, a second parameter, which is 120, close parentheses, semicolon. The semicolon means it's the end of the line. So does anyone remember what setup does? it takes those two different things, right? It takes the first parameter and the second parameter. What's it for? So Barshar said changes the width and height. So it does set the width and height of what? Like it sets the width and height of one particular thing. Like before you start anything else. So yes, it is the width and height, but like what? The width and height of what? Is it like a rect that you're drawing, or like an ellipse, or a line, or what is it? The width and height. So I'll let you guys answer that, and then the box. What do you mean by box? And so you can see that we have like anything that we want to actually draw, we're drawing inside of the draw loop. So that's why we have this line, which is ellipse, and it takes 4 parameters. You don't have to worry about the way it's being done right now, but things you want to draw, they go and draw, right? Things you want to set up. So like for instance, size, which is the size of the window actually. So when you actually write size parentheses, the first parameter, that's the width of the window, comma, the second parameter is the height of the window. So in this case, this would be a width of 480 pixels and a height of 120 pixels. So if we just look back and review a little bit, and it's like a lot harder to ask questions in the chat. So please, like, even if you don't know the answer, can you just like type it in the chat? It makes me feel better. So does anyone remember what an IDE is? I think we talked about this. If not, it was in the slides. Does anyone know what an IDE is? It's an acronym. What does it stand for? It's totally okay if you don't know. That's why we're reviewing it. So it stands for an Integrated Development Environment. An IDE. So an example of an IDE is processing. So that's because it does everything integrated. You can basically create an entire program inside of processing if you wanted to. Development usually refers to like coding or developing some kind of software. Environment, because that's where you do it. What's a good analogy for code? What are some of the examples we talked about last week? Does anyone remember? Like what kinds of things did we compare code to? We went through like a bunch of different examples of things that are like code, or examples of things like visual language that's similar to code. So one of those examples was, we talked about visual language in terms of maps, remember? So I'm just asking what did we compare code to? What did we say it's similar to, or so remember we looked at the subway map, so we looked at the New York City subway map. We talked about the visual language encapsulated within it, how it communicates things to you. So like when you see 2 dots with a line between them, you might know that it's a transfer, for instance. You might know that the different color lines are different train lines. You might know that a circle represents a stop, and then the text next to it represents the name of that stop. Does that sound familiar to people? We also talked about, what did we talk about? We talked about the tablet. Remember the tablet? Does anyone remember what the tablet was called? It had 4 different languages on it. Was it 4 or is it 3? So it has Latin, it has Greek, it has hieroglyphics, and maybe that's it. Maybe it only has 3. And then, yeah, so all that stuff should hopefully be familiar. Oh, and then music notes. That was the other example. So we looked at music notes. When you see music notes, you understand, if you understand how to read music, you know that like the lines represent different, I'm not a music person, chords? Is that what they're called? And then the different like shapes represent different types of things. So Barshar got it. The Rosetta Stone was the name of the tablet you were talking about. So like before the Rosetta Stone, no one knew how to read hieroglyphics, but they did know how to read Latin and Greek. And so that allowed them to compare, and that's when hieroglyphics started to be decoded. And so you can think about like code as hieroglyphics right now. Maybe you don't know how to write hieroglyphics, but we're starting to put the pieces together so that you can understand and you can communicate in hieroglyphics, except hieroglyphics is code. Okay, so how does the coordinate system work? So we talked about the Cartesian coordinates, Cartesian coming from Descartes, the philosopher René Descartes. And so it works similar in processing. So how many axes do we have in processing? How many axes have we used? So we can use like coordinates to position something, for instance. So you may have used the first, so Linda said 2. So 2 axes that's the number we've used. So the x and the y, right? So the x is the horizontal and then the y is the vertical. And so what is the top left-hand corner of your sketch? What is the coordinate for that position? Does anyone remember? That's right, 0, 0. So 0, 0 is the top left. We call that the origin sometimes. Got it as well. So as you move out along the x-axis, the value increases. And then as you move down on the y-axis, the value increases. So 0, 0 is top left. And basically, the further you get away from top left, the higher the numbers go on both the x and the y. And then what is setup? What is it for? I mean, we just talked about it, right? So how many times does setup run? I need to find my fidget cube. I have this tape measure. I like tape measures because I'm weird. So I have another one here. So David said once. Hi Nate. Let me make sure you're included. Cool. But yeah, I need something like safe to fiddle with while I'm like trying to think. Cool. So as David said, setup runs once and then draw runs how many times? I used like a specific way of describing it. So it's a loop, right? So how frequently does it run? I don't know if I said how frequently it runs, but as it gets to the end, it starts on the first line of draw, it executes the code, second line executes the code, third line executes the code, fourth line executes the code, etc. until it gets to the very last line within those curly brackets, and then it starts back at the first line. So that's why we call it a loop. And then it runs once per frame. So like we were talking about animation, right? So animation has like one frame, and then the next frame, things are positioned a little bit differently. And as you get many frames, then you get the illusion of movement. And so draw will run once every frame. So usually when you're running processing, it's running probably 60 frames per second. So when you run draw, it might run 60 times within the course of that 1 second. And so one thing that we really haven't talked about, we need to get into, is variables. So we can think about variables, and there are a bunch of different ways to talk about them. We can think about these as like in terms of post-it notes. If you're like in a design office and you're working with post-it notes, different colors of post-it notes might represent different kinds of things, different categories. What, it's too many post-it notes, you think? And so when we have these, you can like label them whatever you want, but like they're containing a specific kind of thing. So you don't have to worry about it. It's just an image of post-it notes. And yeah, it is a lot to take in if it was like something you're working with. And so we think about variables as something that can store information, and something that stores a specific kind of information. Also something that, like, what do you think is a key component of variable? If you were to look at the word variable, like what words you see within the word variable. Like you could describe it as having like 2 subset words, like 2 component words. So like just like say it out loud. Vary. So Barshar, yes, like vary. And then what's the other part? The vary is to like differ or change. And then David said able, so it's able to vary. And that's like literally what it is. It's something that holds some information, holds some data that can change. So we think about variables as container for holding specific types of pieces of information. And so you might need a different type of variable or a different type of data that you want to store. So you can store data, you can store things like numbers, for instance. So not every container is appropriate for a given type of thing. And so, for instance, I don't know what kind of box this is. This is a laptop box or like a Blu-ray player. It's only good for storing cats, right? So you can't necessarily store an elephant inside of this. It's only good for certain kinds of things. So one thing that's important is that you can swap things in and out of a container. It can contain a cat or it can contain a Blu-ray player. This is clearly a hedgehog container. And this is all just an excuse to be able to show animals in my slides. Hedgehogs look so cute. I mean, I don't know how fun they are to touch. They look really soft on the bottom or the like belly area. And so this is another lovely cat container. If you didn't know, cats are liquid. And so they will fill the shape of the container. It's pretty crazy actually. Like I said, not all containers are made to store everything, right? So in this case, this is clearly not a fox container. Is it a fox? I think it's a fox. So it got stuck because it's not the right kind of container. So I have one cat, and maybe she'll probably make an appearance at some point. In the past, I've had a turtle, I've had fish, I've had geckos, I've had dogs. I like almost all animals. I don't like bed bugs and I don't like roaches. Most others I like. So if we're thinking about like a more technical definition for variable, we can say it's a named pointer to a location in the computer's memory where data is stored. Since computers only process information one instruction at a time, the variable allows the programmer to save information from one point to the program and refer back to it at a later time. Which is a very technical definition. So if you're looking for that technical definition, if that helps you, then there it is. So one thing is that it's an important word here is named. So and when it says pointer, you could think about it as a reference. So it's a named reference. So you have something, you write a label, you have a label, you name it something. So you create a variable, you give it a name so you can refer back to it. So you all have names that's like, you could say that's a variable for someone. And so you can name it, generally you can name it like mostly whatever you want, and it can store a certain kind of thing. So if everyone has a name in here, and you can store like letters in your name, but you can't necessarily store symbols. Maybe like you can't store like square brackets, for instance, or you can't have like an equals in your name, but you can have letters. Right, so a certain kind of thing, it can contain a certain thing. So, although like what was the Elon Musk and Grimes baby? They had to like change the name because it had a symbol in it, I think. So, some really cool things about variables is they can be stored in the computer's memory. So a program can access it and use it over and over and over again. So rather than like writing out the same thing, if you don't remember something, you can just use something's name in terms of like a variable, and then you can also change it while it's running. So for instance, you can have something that stores the amount of like water in a glass. You can say that it has like 5 ounces at one point and then 3 ounces at another point, so you can change how much it's stored. So you can like basically like, you know, mark out the old thing you were storing and then override it with something new. So I mean, you know, people have them as like their like stage names, I guess, but like probably not their legal names, and generally not like the name they go by, because like how do you pronounce the dollar symbol or the pound symbol or, you know, any symbol? I mean, sometimes there are names, but like just generally, right? So you can use variables to keep track of things that are important for shapes. So we've used shapes so far. You've used colors, so you can store information about colors. You can store information regarding sizes, locations. And so this is probably like kind of abstract right now because you're not sure like what specific examples we're talking about. And so we can think about like, here are the first two data types we're going to talk about. So a data type is a type of variable basically. So in the first one right here, we have what's called an int. Does anyone know what int stands for? Or do you want to guess what int stands for? So Barshar said integer, which is correct. So int stands for integer, which is a whole number. If you recall from some distant math class, initialize is a good guess. It's very close. So in this we have examples of whole numbers. So that includes positive numbers and negative numbers. So like 1, 2, -3, 40, 2013. Those are all whole numbers, meaning they don't have anything after the decimal point, meaning they are not fractions. And then the second type is float. The float is probably like, you're like, what is a float? Like, that's a weird name. The float stands for floating point number, which basically means the decimal point is not all the way to the right. So you can imagine with an integer, you can imagine that there's a decimal point. By the way, you can see my cursor. Okay, cool. I'm not just doing this for myself. You can imagine the decimal point as being all the way to the right. So you could imagine this as 2013.0 or whatever, you know, with a bunch of zeros after it. But ultimately, like, you don't need that dot or anything after it to be able to communicate what that number is. So what do you mean by pennywise? I don't know what that means actually. So float stands for floating point number. So anything with a dot and something after it. And you can use it to store something that is like 2.0. Oh, is this, oh, it's a band, right? It's a band, is that right? So we have another example, we have like 0.5. So it has, no, it's not, okay. Sorry, you'll have to explain it to me later. I'm kind of slow. And then we have 1.34. So all of these things have like numbers after the decimal, and you can also use it to store a whole number, but that whole number is using the decimal. So it could be like 5.0. So if it can still be used, it could be used for everything that int can be used for, plus anything with stuff after the decimal point. So floating point number. So some other kinds of data types, we have string, Stephen King's It. So I never read that. I mean, I'm not like is that the clown one? I'm like really losing it in my pop culture points right now. So we have strings are strings of characters. So we could think about like your name is a string because it consists of characters. So for instance, you could also think about like your username, it consists of characters. So like for instance, Eastside_punk_50 consists of the characters E, A, S, T, etc. So it's a string of all of those characters together. And so when we're referring to string, we're talking about things that are being treated as text. So not like numbers or anything else, but just text as itself. When we refer to those, we are using quotation marks so that processing knows that we're talking about strings. So again, if you see string, just think of it as a string of characters. And then Boolean, so have you all heard of the word Boolean before, or maybe like Boolean logic or anything like that? Probably in a math class. So if you haven't heard of it, it usually refers to true or false. So, so you could say something is true or false, not in between, not like so something is yes or no, binary, true, false. There's no like maybe, there's no middle ground. So this is a type of thing that is true or false, like the sky is blue, true or false. Well, right now it's false because it's white. So dang, I thought they taught that in Math 100, is that it? So Boolean logic is it's simple. It's true or false. It can't be anything but true or false. So we can use colors. Color is the data type in processing. So by default, processing uses RGB, so that's like red, green, and blue. So you have, in this example, you have 255 is the red value, 177 is the green value, and 80 is the blue value. So when we want to create a variable, we have to first declare it, and then we have to initialize and assign it. So what that means is that, and there are several ways to write this, but when we're doing it with code, we have the first part. So if we want to declare an integer, we first write int. So that tells processing, you give it the type first. So the type is int, space followed by the name you want to give it. So in this case, what's the name of the integer that we created? So on the second line, we create a float, and it's given the name y. And so these are like arbitrary, these are names that you give it, so it doesn't necessarily correspond to anything unless you mean it to. So it depends on how you use it. And so when we declare these at the beginning, these are things that we want to be able to use throughout our sketch so we can refer to it later. And then when we say something like initialization, which is an initial assignment, so by default, when we create this variable, it doesn't have a value necessarily, and so we have to give it an initial value. So we might also call it an assignment, so an initial assignment. So we have our declarations at the very beginning of our sketch. So we call these global variables. So that means that we can refer to them anywhere in our sketch and it will know what we're talking about. So we declare an int called x, we declare a float called y, and then inside of our setup function, so we write void setup, open close parentheses, open curly bracket, and then we indicate the size of the window, size, and then it's 500 pixels wide by 500 pixels tall, that's the size of our window. And then we assign the initial value of x to be 0. So int again is a whole number, so it can only be like 0, 1, 2, you can't do like 50.5. It wouldn't work. And then for y, since it's a float, that means a floating point, that means basically a decimal number. So we do equals 5.3. So what we're doing is we're saying, take the x variable and give it a value, give it a current thing to store this value. So x, store the value 0. So when I refer to x, it will give me back that value of 0. So if we want to use that inside of our sketch in terms of drawing, we could do something like, and these are arbitrary in terms of how we use them, but we have draw, so everything that we're going to draw will go inside of draw. So we're drawing an ellipse first, and it's like, I have to remember to like kind of duck out sometimes. If I'm like ever in the way of some text, just let me know to like move out of the way. So we declared our variables at the top. We gave them initial values inside of setup. So remember, setup happens once at the beginning. So this is what they start off as. They might change later. And then we use them. So inside of draw, we are drawing an ellipse here. The first parameter is the x position of the center of the ellipse. The second parameter is the y position of the center of the ellipse. So this is at 50 on the x and 200 on the y. And then in this case, the width and the height are both, we're using x. So like, just because we called it x doesn't mean we have to use it for something that's x related. Like I said, it's just like, it's a name. It doesn't necessarily get attached to anything. It's just like if you attach it to a person, and that's what it is. So x has a value of 0. So this will give it a width and a height of 0. So when it draws this ellipse, it will be invisible because it's a width of 0 pixels. So 0 pixels is invisible. And so before you were using something like this, like where you have rect, you have like an x position and a y position of 100, and then you have it as a width of 30 and a height of 50. So you could use variables instead. You could also refer to variables. You can give it both a declaration and an assignment in one line if you wanted to. So you could declare it and initialize it / assign it. So you could write int x, so that's declare a new integer, call it x, that's the name, the second thing is the name, and then equals, meaning give it this value, and and then 0. So create a new variable of the type integer, call it x, and give it a value of 0. And then in the case of the float, declare a new variable of the type float, meaning like a decimal number, give it the name var1, and then give it an initial value of 1.3. And then Boolean, so Boolean again, true or false, it can only be one or the other. Give it a name of Fred. It's arbitrary, so you can name it whatever you want. There are some exceptions, but and then give it a value of true. So Boolean can only be true or false. You can't make it like 1 or 2 or something. It can only be true or false. Are people following along okay? Are there any questions? You can always just like send questions to the chat if you have anything that comes up. So you could create Boolean Marcus. Is Marcus here? Marcus, are you in here? Oh, there's someone named Marcus in the class. We do something called camel case often. So this is a convention. So this is not required, but if you see this, and we're usually going to use this convention, and when we name variables, we often use camel case, which it's named camel case because of the humps of a camel. So let's say our variable name is variable name. If we wanted our variable name to consist of multiple words, we would have it lowercase, except the first letter of each new word is capitalized. So in this case, variable name, but we can't put a space in a variable name. So instead, we just put it together with no space, and then we capitalize that first letter of any subsequent word, and that allows us to read it easily. So has anyone ever heard of camel case? I'm just curious. Well, now you have. Okay. So commenting. So commenting is something that we use in code. So this allows us to write things that are not executed by the compiler. So it will, if you write something in this way, so we have two different kinds of comments. One thing is 2 forward slashes. Those are the slashes that are like to the right on the top and the bottom left. So like bottom left to top right is the way the line goes. So we have in this way, so like anything after those 2 forward slashes will be grayed out in processing, meaning that it will not execute the rest of that line. So in that case, we can leave notes basically for ourselves or for other people that are reading our code. And so it's considered really good practice to leave comments for yourselves and for other people who are reading your code. So because what happens when you're writing code is that you let's say you're like coding something for like 3 hours, and like you've like built up this mental model in your head of exactly what's happening, so you know what everything does, and then you like step away and come back a week later, and what happens is you don't remember anything. You don't remember what you were doing or what this point was or what that was, and so we have to leave comments to make sure that we remember what things are. So they're basically notes for ourselves, and they're super important. And then of course, if you're looking at someone else's code, if they don't have comments, it's going to take you a very long time to understand what they're doing, or maybe you won't understand at all. So it's important for us to leave comments for other people because they might look at our code because we share our code, right? So here's another type of comment here at the bottom. So we have, this is what's called a multi-line comment. So it will, you initialize it by doing the forward slash and then the asterisk symbol. That's like the star symbol. And so like everything after that forward slash and asterisk will be commented out until you do an asterisk and a forward slash, which will close out the comment. So then you can resume typing code. Does that make sense? Those are the 2 types of comment: single line comment and then multi-line comment. Okay, so when we talk, and by the way, is the music too loud or is it an okay level? I forgot to ask that earlier, because I never know, because it, like, you know, It's like at a different level in my headphones. It's okay? Okay, cool. I think last time I listened to it, I was listening to the recording and it was like very low, so you couldn't hear it. God level, that's the phrase of the day. So all variables must have a type. How's it going? Mas tacos, please. I was like, what's your name? And I was like, oh yeah, it's Mas tacos, please. So Mas tacos, please is from some other classes. So we have variables, we have a type. So like for instance, when we declare a new integer, we say int. So that's like how it knows like what type of memory to store, how to allocate that. What kind of move? What kind of move are you making? Hopefully not in class. And then a name, right? So you have like, for instance, int, and then the name. So like you have to give it a name so you can reference it later on. And so some of the rules for like how you name variables. So you can generally use whatever you want as long as it doesn't have spaces and doesn't have special characters in it. So you don't want to use things that already exist in processing. So there are some like words or terms that are already used as like variables that are built into processing. So, and we'll talk about more examples of that later. And then you want to use names that mean something in terms of how you're going to use them. That's not required. It'll still work, but it just helps you to read the code more easily. So you want to make sure that it means something. So don't just name it like variable 1, variable 2, variable 3, because then you're not going to remember what those were used for or like why you made them. And so it's good practice not to start your variable names with capital letters. It's better to use camel case, where everything is lowercase except the first word of a new subsequent word within the name. And so we'll talk about more about why that is at some point. And then so some examples. I'm sorry, I hope this is big enough. Here we have an integer. It's named count. Hi Brianna. I gotta mark your username. Okay, cool. So we have an integer. It's integer is the type, and then the name is count, and the value is 0. So give it an initial value of 0. That value might change later on, but for now, let's start it at 0. So this is when you haven't seen, right? So what is the type here? Do you know what the type is? Just following the same formula of what we've done before. So if the first one was of type int, what's the second one's type? So in this case, it's not a float. So float was the other type we talked about, but like this specific one. So like you don't know what this means necessarily, but just like following the same formula, if the type of the first one is int, what's the type of this line? So we said that the type comes first and then the name, and then potentially an assignment, which is like equals whatever the thing you're gonna assign it. So in this case, the type is char. So even if you don't know what that is, now that you know that the way it's written, you can understand what's happening here. So char is the type. Does anyone want to guess what char stands for? So in this case, it's giving this new char that it's declaring a name of letter, L-E-T-T-E-R, and then it's giving an assignment of A with single quotation marks. No one wants to guess on what char stands for? So David's right. So it stands for character, NTJ. So in this case, if you're going to refer to a char, it's another data type. You have to use single quotation marks for that character. Linda too, you got it. And so this is another type you haven't seen. So what would the type here be? So the name that this variable is being given is I. So Zaire said double, and that's right. So it's a double, which is the specific. It's basically like it's like a float. So it's not actually an integer, but it's so like the I here is not actually part of the type. It's the name that it's being given. So the type here is double. The name is I, and the value it's being assigned initially is 132.32. And so like once you know how this works, you don't even need to know necessarily what it is to be able to read it. So in this case, we have a Boolean, and then what's the name being given to this Boolean? Boolean's reminder can store true or false, and that's it. They can't store anything else. They can't store numbers or anything like that. So the name is happy. So a lot of times you'll use Booleans with if statements, which we'll talk about later, as Brianna mentioned. And so here we have float, that's the type, x is the name, and then the value it's being given is what? I think there's like a little bit of a delay in the chat. Makes it hard to communicate. That initial value is 4.0, etc., etc., etc. So you got it, Barshar. Okay, so we can also do things like this. We can say like y, which might be an existing variable that we've declared, equals something else, like another variable plus an amount. So it can say like take whatever that other value is and add this. So if this was the initial assignment for y, what would the value of y be? If x is 4.0 and y equals 4.0 plus 5.2, then what is that? We try to keep the math very easy in this class. So 9.2. So like if you know one variable, you can use it for another variable in terms of the assignment. Okay, so let's see. This will be in the slides. So let's see, how many minutes do we have? We have 25 minutes. Okay, cool. So if we're thinking about the game of Pong, right? So hopefully everyone's familiar with Pong. It's a pretty classic game. The two paddles move up and down, and there's like a ball that's moving. So if you're trying to imagine like things that change, things that might change in terms of like various like data you want to store, what might be some examples of some things you might want to store using variables in processing? So remember, remember we're talking about processing. So like you remember you were drawing shapes, so you had to like use certain things to indicate that shape. You had to use things. So for instance, we might talk about like a paddle y position, right? So it moves up or down. So that's something that we could use a variable to store. So Brianna said the score. So you might, and in this example, it's like two scores. So there's like a player 1 score and a player 2 score. So you might have two variables for that. They're probably integers. David said the ball. So you might have an x position for the ball and a y position for the ball. You might have like an x speed for the ball and a y speed for the ball. You might have like so those are some pretty good examples. So if we were to like think about like what kinds of things we might want to score, so I just have a list of these. And so now let's take a look at the stuff we did last week, thinking about how we could use variables and replace the hard-coded values. So if you see the term hard-coded, does anyone know what that means? And it's okay if you don't. I don't expect people to know what it means. So I'm going to open up processing. So if you don't remember, this is what we had last week. So yeah, we are, no, not hardcore. So hard code. So hard coding, I mean, it's probably not hardcore coding. Your eyes, I'm sorry, the colors are awful. Let's fix that. Maybe we should change these colors, like, I don't know, like 50, 50, 200. Maybe this one could be like 30, 240, 30, maybe. Are those all the colors in the background? That's a little nicer, right? I mean, they still clash, but at least you can see the difference between them. So when we say something is hard-coded, we mean that if you want something to change in here, you have to go in there manually and change every single line. So the first thing we're going to do here with the stuff we did last week is we're going to make sure that we use our setup and draw functions. So yeah, so usually, like, if you have like very extreme differences in the red, green, and blue value, the more extreme the difference, the more, like, the brighter the color is. So like if you have like things that are a little bit closer together, it makes it look nicer. So I'm gonna first create our setup function. So that's void setup, open parentheses, close parentheses, open curly bracket, and I'm gonna make sure that size is encapsulated within it. So size will set up the size of our window. So I want to make sure that that's inside of it, because that's something that's only going to happen once at the very beginning. And another thing that we're going to do is when we're writing code, we usually like to indent things based on what's called scope. So that, like, if I indent this using the tab key, I know that this is within setup. So it allows me to see everything that's within setup will be indented a little bit, so it makes it easier to read. Another thing you can do is Control T or Command T will auto format your code if you're lazy like me. So now we have all the stuff that we're drawing. So since these things are all things we're drawing, we're going to put this inside of draw. So our draw function, so that's void, which is actually the type of the function. Draw is the name of the function, and then open and close parentheses, and then open curly bracket. Everything we want to be within draw. After that first opening curly bracket, and then when we're done, we add the closing curly bracket. And then I'm going to do Control T on the keyboard, which will indent everything so it makes it look nice and clean. So now I know that, like, this is the start of draw, it's indented, it's not indented at all, and then the close of draw is not indented at all. So it's very, do you see how that's like easier to read? And so let's say that we wanted to, instead of, let's see, let me look at this again. Let's say that instead of, if I wanted to, like, not, let's say I don't want to see this rectangle anymore, but maybe I want to bring it back in later. So I can do something like I can comment out this line. So I added those 2 forward slashes, and you see that it's grayed out. So what that means is that it's not going to execute that line of code. So if I run this, so it will not draw it. So we have this ellipse that's in the middle. So let's say that I want to draw a second ellipse that's like, let's say I want to make a row of ellipses. So what I can do is I can copy this line and paste it 3 times. And so right now I've drawn it 3 times. They're all stacked on top so you can't see them. But let's say I want to make the X position of this one like 200 or like 100, I guess. No, yeah. And this one maybe like 1100. So if I run this, you can see I have like a row kind of ellipses. And so I have, they're in different X positions, but the Y position is the same, right? So if I want, since that's repeating, it might be helpful for us to create a variable for it. So it's a whole number, so what type might be good for, what type of variable, what type of data type should we use to store a whole number? Anyone remember whole number? So Zach said int. So count, I mean, you might give it a name. So in this case, I'm going to give it a name that describes what I'm going to use it for. So I'm going to use it, instead of writing 400, which we'd call hard coding, I'm going to use a variable. And so what this has in common, each 400, it's the y position of the ellipse. So Brianna, isn't int a whole number and float for a decimal? That's right. So float can also be used for a whole number, but with the decimal. Integer can only be used for a whole number. So I'm gonna call this y pose. Y pose stands for y position. So int stands for integer, and then we gave it a name. We want to make sure that name represents what we're using it to store. So I want to give it, so I did my declaration at the top, and then I want to give it an initial assignment and initialize it. So inside of setup, after I do size, I'm going to write y pose equals 400. So I'm giving it an initial value of 400. So now instead of writing 400, I can put y pose. So I replace each of those, and if I run it, it looks the same right now. But now we can do some interesting things with that. So if I want to change this, so remember, variable able to vary. And so if we wanted to change this value, we could. Like if we wrote 400, it would be hard coded, meaning that 400 can never change. 400 is always 400. If it's 401, it's not 400 anymore. But y position is something that's a container, right? So that thing that's within it can change. So what we can do is I can actually modify that value for y position, for y pose. So like if I write y pose equals, so I can assign a new value by saying equals. And then if I write y pose, that means give it a value that's the same, plus 1. What that's going to do is each frame that draw runs, it's going to take the value of y pose and add 1. So what's going to happen is, let's see, every frame it runs, it's moving down. And so if we just had it at 400, we wouldn't be able to animate that, right? So I could also, if I wanted to change the initial value, instead of setting it at 400, I could just set it at 0. So it starts at the very top. And so I only had to change it in one place. I didn't have to change it on each line, which is nice. I want to get rid of that line too. So I'm going to comment out that line so it looks a little bit cleaner. So does that make sense, what we've done so far? So we put everything inside of setup and draw. So we put the things that happened initially at the very beginning inside of setup, and then anything we wanted that was going to change or to be drawn, we put inside of draw. And you do the same thing for y2 and x2. So we could make things like we could make variables to store other things. So if you mean that like for like the x position, so if we wanted to, like right now these are all different, so but I could create int x pose 1. So I could create a variable, since they're all different, I don't want to use the same variable for each one. So I could create like x pose 1 equals 100. And so instead of writing 100 here, I could write x pose 1. So like that. If I wanted to like move that one as well, I could write x pose 1 equals x pose 1 plus 1. But now you can see that one is moving over to the right because that x variable is changing, like for 300 and for 500. Oh, so you mean for the width and the height. So like when we have these are repeating, right? So Brianna pointed out that like these might be good candidates for variables. So I could also make an integer called, I'll just call it oval. I'll call it oval W, which stands for width. and I could make one called int oval h, which stands for height. Oval w equals 300 because we know that that value is 300 used throughout. And then oval h equals 500. So then I want to make sure that I replace these. So, and I'm just copying and pasting if you're wondering what's happening. So I just highlighted this, I double clicked on it, and I did Control C if you're using a Mac, Command C. And then I highlighted this by double clicking it and did Control V or Command V on a Mac. And so I can do the same thing with oval H, oval H, oval H. And so if we're not modifying it, it looks the same, right? But if we want to move those, we could. So like, let's say we want to move them, or sorry, if we wanted to scale them. So if we wanted to scale them over time. So I could say like, for instance, oval H equals oval H minus 1. So what's that going to do to the height of the oval if I run this? So Barshar said go backwards. So, and then Brianna said it's going to decrease. So I think you're getting at the same thing. So let's see. So we can see that like over time as they go down, they are decreasing, right? So like that height is going down, and then at some point it gets into negative actually. And so that's when it starts to get bigger again, because it's a negative value. So instead of like drawing it one way, it draws it the other way. So it does invert. So like if that like confuses you, just remember that it's just decreasing and then it becomes a negative value. So we could do the same thing for like, maybe if I wanted to make it, let's say I wanted to, instead of changing it by a whole number, let's say I wanted to use a percentage. Let's say I wanted to make it, each time it runs, I want it to be 99% as much as it was last time. So if I wanted to do that, then I could change this from an int. So 99%, if we were to represent it using a number, it would be 0.99. If you recall, like if you want to convert a percentage into a number, you move the decimal point 2 positions over to the left. So I can write float so that it's a float instead. And then you can still write this like this if you want to write 500, or you can write 500.0 so it's clear to you that it's a float. And so if we wanted to modify this, we could say oval h times 0.99. And so what this will do is it will multiply it times 0.99, so it'll make it 99% of its previous value each frame. So like the first time it'll be 99% of 100%, and then the second time it'll be 98% of 99%, and so on. So let's see how that differs from the way we did it before. So since it's doing it by a percentage, this time when it starts to get smaller, it first moves at a rate that's pretty quick, and then it moves very slow. So, and it never goes into the negative territory, because like even if it's like 1 pixel tall, that means it's going to be a little bit less than 1 pixel, but it's never going to be negative, because if we're subtracting 1 each time, you know, eventually it gets to 0 and then -1 and -2, etc. I'll just run this again. You can see some of that movement that's happening here. So were people able to follow this so far? Does this stuff make sense? Or are you like, what the fuck is she talking about? So hopefully like the key for like working with code is to practice. So so this is actually a different class. So you're actually in an earlier class. So there's another class happening after this. But this is GD105. Welcome, Nick. Right? That's Nick. Can you divide in processing? So you can. So you could say divide by 99.99, sorry. And so what that does is it actually makes it bigger. And so those are like some of the basics of like using variables. Has anyone seen no stroke? Has anyone tried no stroke in their own sketch? If I write no stroke, open and close parentheses. So if you're on the reference page, you might have seen this. So what this does is it doesn't draw the outline. I usually don't like the outlines. So now when it draws our shapes, you can see that it looks a little bit cleaner. It's more of like a flat look. It reminds me of this assignment where I had to make an image bounce around the screen, just how the DVD bounces around the screen. So yeah, you could recreate that assignment in processing if you wanted to. But it's okay, you're always welcome in our class, any class. These wouldn't be public if you weren't welcome. Or you wouldn't be welcome or you're welcome. Cool, so yeah, so hopefully folks are able to get that, but the important thing is practicing this so that you can, if you don't understand it now, you can understand it later. So like if you see this later, you're like, I don't remember what this means. I was like, you know, in the bathroom when we were talking about this. So it's important to write comments. So I can write y pose equals y pose plus 1. So I could write a comment using the 2 forward slashes, and I can indicate make y pose self plus. So make y pose itself plus 1 each frame. So each frame that it runs, it will be it'll have a value that's 1 bigger than the last frame. And then I can write make oval H 99% of its current value. Yes, please start the one of us chant. Cool. So I'm just writing comments so that when you go back and look at this later, you'll be able to see it. So no stroke. So if I'm doing no stroke, that means like don't draw the outlines of shapes. Clear our background with this color. Set the fill value. Draw our first ellipse. And then I think you get the rest. So I'm gonna write declare a new int. Oops, I got a typo here. Declare a new int called y pose. Give int an initial value of 0. So in all those comments that I just added, they don't do anything for how it runs. It's just a note for us. So when I run this, it still looks the same, nothing's changing. And so what I'm going to do is I'm going to upload this to open processing. Let's see. And so I'm going to create a new sketch on open processing. I'm going to take this code, I'm going to get rid of it, and I'm going to paste in the code that I just did. And notice how it has these errors in here. You have to make sure that you remember to switch it to processing.js, and then when you run it, you can then see what it looks like to make sure it's working correctly. So I'm going to go ahead and save this. So I'll call this GD105 underscore F20, that's fall 20, underscore lesson 2. I'll just call it L2. Will you remember that's lesson? And then variables. Since this class is like it's like weird weeks, that's why I'm calling them lessons instead of weeks, so people don't get confused. It'll probably confuse people anyways. So the homework will be to use variables and stuff. So you're going to be creating like an animated thing inside of processing. You're going to make sure that you use setup and draw to organize your code, and you're going to have things moving over time. So you're modifying those values. So there will also be some more slides that you'll be able to look at, and hopefully they'll answer some questions. You'll be able to read my notes that are also in there. And so for Monday, you need to bring in your initial prototype for this so that people can look at it together in class. And then you can finish it. So everyone should have a basic like animated thing. So if you want to like make your, if you want to, you could like do something like you could make a scene, for instance. And I don't know if I have specified what it is, but like you could have like something, you could have like a character moving along a background, and so you'll have to have like a certain number of animated elements. So I'll post the specifics for that on River later today once I get done with my class that's right after this. But yeah, so hopefully that made sense, enough sense for people. This stream will be up in a recording, so if you need to review it, it'll be there. I'm going to post the slides and the homework specifically later. Trying to put the blunt down for a bit. So, I mean, different people code differently. It helps some people, it hurts some people. I would not be able to code if I was high. Not at all. No way. Like makes my ADHD like really bad. Not that I know anything about illegal drugs. I don't know anything about illegal drugs, by the way. Okay, cool. So yeah, that's it. So it's basically 1:45. So that's the end of class. So I'll post the stuff later today on River. So yeah, thanks for tuning in. I hope you have a great day. You're gonna bring in the prototype on Monday, and yeah, have a great week.